Imagine a place in space where gravity is incredibly strong. So strong that it defies our everyday understanding of how gravity works. So strong, in fact, that nothing, not even light, can escape its pull. This means that once something gets too close, it is pulled in and cannot get out. This place, my friends, is called a black hole. Black holes are one of the most fascinating and mysterious objects in the universe. A black hole is a region in space where matter has been squeezed into a tiny space. This compression is so intense that it creates a gravitational pull that is incredibly powerful. This creates a gravitational pull so strong that nothing can escape. Black holes are invisible to the naked eye. This is because they don't emit any light. They are essentially invisible, making them even more mysterious. We can, however, detect them. Scientists use powerful telescopes and other instruments to study the effects of black holes. We do this by observing how they affect nearby stars and matter. For example, we can see stars orbiting around something invisible, which indicates the presence of a black hole. Black holes are mysterious objects. They challenge our understanding of physics and the nature of the universe, but they play a crucial role in the universe. They are not just destructive forces, they also have a significant impact on their surroundings. They influence how galaxies form and evolve. Many galaxies, including our own Milky Way, have supermassive black holes at their centers. They are a testament to the incredible forces at play in our cosmos. Black holes remind us of the vast and powerful universe we live in, full of wonders yet to be fully understood. To understand black holes, we need to talk about gravity. Gravity is a force that pulls everything together. It's what keeps you on the ground and the Earth orbiting the sun. The more massive an object, the stronger its gravity. Now imagine an object so massive that its gravity becomes incredibly strong. So strong that it pulls everything towards it, even light. This is the kind of gravity we're talking about with black holes. Think of a bowling ball placed on a trampoline. The ball creates a dip in the trampoline's surface. That's kind of like what a black hole does to space-time. It creates a dent so deep that nothing can climb out. How does a black hole form? It's from a dying star. Stars are giant balls of hot gas that shine brightly. They are powered by nuclear fusion, which happens in their cores. Fusion creates energy and keeps the star shining. Massive stars live fast and die young. They burn through their fuel much faster than smaller stars. When a massive star runs out of fuel, it can no longer support its own weight. The core collapses in on itself. This collapse is incredibly violent. It triggers a supernova, a powerful explosion that can outshine an entire galaxy. The outer layers of the star are blasted out into space. Sometimes, after a supernova, the core of the star is left behind. If the core is massive enough, it will collapse further under its own gravity. This collapse continues until the core becomes a black hole. These black holes, formed from the remnants of massive stars, are called stellar black holes. They are much smaller than supermassive black holes, but still incredibly dense. Imagine squeezing all the matter in our sun into a space the size of a small city. That's how dense a stellar black hole is. Lurking in the hearts of galaxies lies at the center of most galaxies, including our own Milky Way, lies a supermassive black hole. These are black holes of monstrous proportions, millions or even billions of times more massive than our sun. How do these behemoths form? That's a question that still puzzles astronomers. One theory is that they formed from the collapse of giant gas clouds in the early universe. Another theory suggests that they grew by merging with other black holes over billions of years. These supermassive black holes play a crucial role in the evolution of galaxies. Their immense gravity influences the orbits of stars and the shape of the galaxy itself. There's a third type of black hole that scientists believe might exist: primordial black holes. These are thought to have formed in the very early universe, shortly after the Big Bang. The early universe was a hot, dense soup of particles. Tiny fluctuations in this soup could have created regions dense enough to collapse into black holes. Primordial black holes could be incredibly tiny, even smaller than an atom. But don't let their size fool you. They could still pack a gravitational punch. While peering into the abyss, how do we see black holes? Black holes are invisible, right? So how do we know they're out there? While we can't see black holes directly, we can detect their presence through their effects on their surroundings. One way is by observing the orbits of stars. If a star is orbiting a very massive object that we can't see, it could be a black hole. Another way is by looking for X-rays. As matter falls into a black hole, it heats up and emits X-rays. By studying these X-rays, we can learn about the black hole's properties. Now you might be wondering, could a black hole swallow Earth? The idea of a black hole swallowing Earth might sound scary, but there's no need to panic. Black holes are fascinating cosmic phenomena, but they aren't the universe's predators. Black holes don't wander around the universe like cosmic vacuum cleaners. They are formed from the remnants of massive stars that have ended their life cycles. Black holes follow the laws of gravity, just like everything else in the universe. They exert a gravitational pull, but only within a certain range. For a black hole to pose a threat to Earth, it would have to come very close to our solar system. This is highly unlikely given the vast distances between celestial objects. The chances of that happening are incredibly slim. In fact, the nearest known black hole is thousands of light years away from us. In fact, if our sun were to suddenly become a black hole, don't worry, it won't. It would have to lose a lot of its mass first. Earth's orbit wouldn't change much at all. The gravitational pull would remain the same because the mass of the black hole would be the same as the sun's current mass. We would continue to orbit the black hole just like we orbit the sun now. The mechanics of our orbit are dictated by the mass of the object we are orbiting. The only difference is that it would be very dark and cold. Without the sun's light and heat, Earth would become a frozen wasteland, unable to support life as we know it. Black holes come in different sizes, from small stellar mass black holes to supermassive black holes found at the centers of galaxies. These supermassive black holes can have millions to billions of times the mass of our sun, but they are far away and pose no threat to us. So, while black holes are indeed powerful and mysterious, they are not something we need to fear in our daily lives. The universe is vast, and our tiny corner of it is relatively safe from these cosmic giants. Even though that hasn't stopped NASA's quest to understand black holes. NASA is actively studying black holes using a variety of telescopes and spacecraft. The Chandra X-ray Observatory, for example, is specifically designed to observe X-rays from black holes and other cosmic objects. By studying black holes, we can learn more about the fundamental laws of physics and the evolution of the universe. Black holes are still shrouded in mystery, but each new discovery brings us closer to understanding these fascinating objects. Black holes are one of the most fascinating and mysterious phenomena in the universe. They captivate the imagination of scientists and the public alike. If you could somehow compress Earth into a black hole, it would be about the size of a marble. This is because black holes are incredibly dense, with all their mass packed into a very small volume. Time slows down near a black hole due to its strong gravity. This phenomenon is known as gravitational time dilation. The closer you get to the black hole, the more pronounced this effect becomes. This effect, known as time dilation, is one of the strange predictions of Einstein's theory of general relativity. According to this theory, the presence of a massive object like a black hole warps the fabric of space and time. Black holes are not actually holes in space. They are regions where the gravitational pull is so strong that nothing, not even light, can escape from them. They are incredibly dense objects with a lot of mass concentrated in a small space. This density is what gives black holes their powerful gravitational pull. Some scientists believe that black holes could be portals to other universes or dimensions. This idea comes from the concept of wormholes, which are theoretical passages through space-time. However, this is still highly speculative. While the mathematics of general relativity allows for the possibility of wormholes, we have yet to find any physical evidence of their existence. Black holes are some of the most intriguing and mysterious objects in the universe. They challenge our understanding of physics and push the boundaries of what we know about the cosmos. They continue to fascinate and challenge our understanding of the cosmos. Scientists are constantly studying black holes to learn more about their properties and the role they play in the universe. As we continue to explore the universe, we are sure to make even more exciting discoveries about these enigmatic objects. The study of black holes is a dynamic and ever-evolving field, promising new insights and revelations about the nature of our universe.